Good day everyone, I am Kay Galiza Nazareno from BSCS4A and I'm going to discuss to you about semaphores. So let us first define what is semaphore. So semaphore was proposed by Dijkstra in 1965, which is a very significant technique to manage concurrent processes by using a simply integer value, which is known as a semaphore. So semaphore is simply an integer variable that is shared between threads. So this variable is used to solve the critical section problem and to achieve process synchronization in the multiprocessing environment. Here are some characteristics of semaphore. So number one, it is a mechanism that can be used to provide synchronization of a task. Number two is it is a slow level synchronization mechanism. Third is semaphore will always hold a non-negative integer value. And lastly, semaphore can be implemented using test operations and interrupts which should be executed using file descriptors. So there are two types of semaphores. So the first one is the counting semaphores and the second one is the binary semaphores. So let us first define what is counting semaphores. So counting semaphores, it is a type of semaphore uses a count that helps tasks to be acquired or released numerous times. So if the initial count is equal to 0, so the counting semaphore should be created in the unavailable state. So while the binary semaphore, it is quite similar to counting semaphore, but their value is restricted to 0 and 1. So in this type of semaphore, the wait operation works only if the semaphore is equal to 1 and the signal operation succeeds when semaphore is equal to 0. So it is easy to implement down counting semaphores. So let us now proceed to the example of semaphore. So the below given program is a step-by-step implementation which involves uses and declaration of semaphore. Wait and signal operations in semaphores. So both of these operations are used to implement process synchronization. So the goal of this semaphore operation is to get mutual exclusions. Next one is wait for operation. So this type of semaphore operation helps you to control the entry of a task into the critical section. However, if the value of wait is positive, then the value of the wait argument is x. It is decremented. So in the case of negative or 0 value, no operation is executed. So it is also called PS operation. So after the semaphore value is decreased, which becomes negative, the command is held up until the required conditions are satisfied. So next one is the signal operation. So this type of semaphore operation is used to control the exit of a task from a critical section. So it helps you to increase the value of the argument by 1, which is denoted as VS. Let us now move on to the last part of the discussion, which is the advantages of semaphore. So here are the benefits of using semaphore. Number one is it allows more than one thread to access the critical section. Number two is semaphores are machine independent. Third one is semaphores are implemented in the machine independent code of the microkernel. And then fourth, they do not allow multiple processes to enter the critical section. Fifth is, as there is a busy waiting in the semaphore, there is a newer wastage of process time and resources. Number 6 is they are machine independent, which should be run the machine independent code of the microkernel. And lastly, they allow flexible management of resources.